Audio recording for this meeting has begun.
Again, good afternoon, everybody, and welcome to the NICR, National Institute for Congestion Reduction webinar series. This webinar is sponsored by NICR, which includes the University of South Florida, Texas A&M University, and its affiliated Texas A&M Transportation Research, the University of California, Berkeley, and the University of Puerto Rico, Mayagüez. It is my pleasure today to welcome you to Pricing Mechanisms for Managed Lanes with our presenter today, Alberto Figueroa Medina. Let me tell you a little bit more about Alberto before I hand the presentation over to him. Alberto is a civil engineer, specialist in transportation and infrastructure systems. He has a Bachelor's of Science in Civil Engineering and a Master's of Science in Civil Engineering from the University of Puerto Rico, and a PhD in Civil Engineering from Purdue University. He is a Professor of Transportation Engineering, Director of the Civil Infrastructure Research Center, and the Associate Director of the Department of Civil Engineering and Surveying at UPRM. He has experience in the administration and operation of transit systems in Puerto Rico as a President and General Manager of the Metropolitan Bus Authority, and the first Executive Director of the Puerto Rico Integrated Transit Authority. So with that, I'm going to hand the presentation over to Alberto. So Alberto, take it away.
Okay, thank you, Stephanie. Thanks for that introduction, and welcome everybody to this webinar. Today I'm going to talk about the results we had here at Mayagüez as part of this project from NICR that the official name was Comparing Pricing Mechanisms for Managed Lanes. I'm going to present basically today the results from the case study that we did from the Puerto Rico 22 freeway that has a dynamic toll lane facility. We have some data with that and we analyze it as part of this project. So in terms of the agenda, I'm going to have 5 different sections, basically to talk about the case study and obviously talk about the results from the performance metrics. So I appreciate and thank NICR for this opportunity to present these results and share with you this project with all of you. Okay, so let me start by saying that this project was a collaborative effort between the University of Texas A&M with a team that was led by Dr. Mark Burris from the Civil Engineering Department and the team from Mayagüez. As you can see, we had, as well as civil engineering professors and students, we also had a part related to economics. We have Dr. Del Valle and Isaac, who are from the economics department, who had the chance to evaluate economic metrics as part of the project. So part of my presentation will include those results as well. So you can see that we have a good research team. In the case of Texas, they look at 6 different locations of managed lanes, and they analyze those. We analyze the case of Puerto Rico PR22, and we have detailed data about the transaction that we use for the different analysis we perform in the project. So you see now a picture of the project team here at Mayagüez. So thanks and nice to have you all here. So let's talk with an introduction about managed lanes. Obviously, managed lanes in the United States is one of the innovative solutions that are being implemented to look for congestion mitigation strategies. There are about 73 managed lanes in the U.S. From information from the TRB Managed Lane Committee that they have identified 73 different facilities, and more than half of those facilities, as you can see, are located either in California or Texas. So basically, the bigger states have more experience, but obviously this type of solution has spread across different urban areas. In the case of Puerto Rico, we actually have 2 facilities, managed lane facilities. The second one opened actually early this year. So and there are 40 facilities planned or on the construction in the U.S. So managed lanes are taking, tracking the United States. More projects are being developed day by day. And obviously, managed lanes come in different flavors and colors. Basically, at the beginning, we hear about HOV lanes, HOT lane, busways, but nowadays, managed lanes have different characteristics that basically are related to pricing, eligibility characteristics, access control, traffic management technology. So basically, the range of possibilities now has become more diverse. And obviously, with that diversity, the complexity of the facility also increases. In the case of Puerto Rico 22, Freeway 22, you can consider that as a multifaceted facility, but because it includes express lanes, a reversible operation, and also it has a dynamic pricing mechanism. And an additional characteristic is that it is shared with a busway. So you can see we have four of the elements on that figure that is presented from the NSHRP project 835 about managed lane. So the Puerto Rico 22 managed lane facility has some characteristics that make the possibility of having a complex operation on it. Basically, managed lanes has two different variable pricing mechanisms that are being used. Either time of day or dynamic pricing. In this case, these two primary pricing methods for managed lanes on freeways, the time of day provides predetermined toll rates based on historical traffic flow patterns. Obviously, they are predictable, easy to understand for the users. But on the negative side, it does not react to real-time traffic conditions or incidents that might happen on the street. Basically, you have set the price of the facility before the start operations. In the case of the dynamic pricing, yes, you can now have strategically located sensors that collect real-time traffic data and applies an algorithm to estimate flow parameters, either based on densities, based on speed, and that adjusts the price that the user will have to pay for the use of the facility. Obviously, it has more flexibility because it can handle then those fluctuations in traffic from day to day. But on the negative side, you can think that it's a black box, especially with the case of the algorithm, the pricing algorithm, is something that enters data and exits a pricing. So in some cases, the algorithm basically is not available, and obviously the higher cost for the implementation of the technology, the sensors, and the data collection, but obviously has a higher price for the facility. No matter the type of mechanism, obviously the performance of the managed lane is the main factor for setting up those prices. So basically, the objective of this project at the NICR level was to compare different facilities to detect if either of those mechanisms has a better advantage one over the other. So basically that was the main project objective, to be able to analyze if either one of those pricing mechanisms was better than the other one. In our case for Puerto Rico, we also included obviously the need for the case study, being that the PR22 was the first managed lane with a dynamic pricing mechanism established in Puerto Rico. So we wanted to look at the user frequency, preference, and opinions about the DTL. So we expanded a little bit more the objective that we had with the project from NICR. So that's basically what I'm going to show you today. Dr. Berries had a previous webinar some months ago, and he presented the results from 6 different managed lanes facilities. Obviously, this one it will be like a 7th facility, and at the end, I will show you a table comparing some of those results. So let me talk a little bit about the Jose de Diego Freeway PR22 dynamic toll lane, so you can understand the basic operation of the facility. The PR22 dynamic toll lanes is located in the San Juan metropolitan area of Puerto Rico. Obviously, Puerto Rico is located in the Caribbean Sea next to the Dominican Republic. But as you can see from the TTI Urban Mobility Report, San Juan area has a lot of congestion. Congestion has significantly increased from 8 hours of delay in 1982 to 58 hours in 2017. So that's a 625% increase. So that's huge. When you compare with other urban cities in US, the San Juan metropolitan area has higher values of delay than Cleveland, Indianapolis, in Cincinnati, Minneapolis, and even Las Vegas. So obviously, the San Juan metropolitan area is ranked in the top positions in terms of metrics related to congestion. For example, we are number 4 in terms of planning time index, number 15 in terms of travel time index. So obviously, in Puerto Rico, they decided that for this corridor, PR22, that is located on the north side of the island, PR22 is the most heavily traveled facility in the entire territory with ADTs over 200,000 vehicles per day. I don't know if you can see my pointer, but if you see on the map, Arecibo is located on the north side of Puerto Rico, and you can see PR22 extending from on the western side of the island all the way to San Juan. So that corridor is the PR22. Like I said, it's 52 miles long, and what you can see on yellow, marked on yellow, is the DTL. It's actually the DTL that is 7.7 miles in length. So you can see that to enter San Juan, you have the option of using the DTL on the PR22 corridor. And you can see a photograph of already in the San Juan area, a little bit patriotic, right? You see the flag of Puerto Rico, and looking at the congestion, everyday congestion at the commuter time in the morning. So you can see it's a eight lanes all the way, four in each direction, and heavily travel. This is stop and go conditions, so you don't have any flow at all. It's just stop and go almost every morning. So obviously we wanted to look at the efficiency of this facility. The lanes, the facility has 2 median lanes, and it's a reversible operation, going towards San Juan in the morning, exiting San Juan in the afternoon. Another characteristic that make this PR22 interesting case is the toll pricing. Like I said, the dynamic toll lanes has a variable toll rates that goes from 170 as a minimum to 495 as a maximum value. The variable mechanism, the pricing mechanism, is based on the speeds on the median lanes. So they have used 55 miles per hour as the threshold for changing the rate of the tolls in the dynamic toll lanes every 5 minutes. But as you can see, the regular lanes also has a toll. In this case, it's a fixed toll, but on the same corridor, you have the DTL with a variable pricing mechanism, and you have the regular lanes or the general lanes with a fixed toll of 75 cents. So you can see that the users of the freeway are already paying for the use of the facility, and they have to pay a premium if they want to go enter the median lanes to access the express lanes on the facility. So that makes for an interesting case of how the user decide to use or not the DTL. And you can see here a configuration, a plan view of the configuration. I'm not going to get into more details into this one, but in the morning operation, we have 2 entry points, and then you have 2 exit points in the morning going towards San Juan. They use movable concrete barriers to create 1 lane, especially at the end. This one, you can see that they extend the dynamic toll lanes to have a second exit going towards San Juan. But as you can see, the regular lanes also have toll lanes, toll stations inside the DTL corridor and after the DTL corridor. So this is a complete corridor that has a toll scheme that people obviously are used to it. And also, like I said, it has a busway that connects through the DTL to the DTL corridor as well. And during the afternoon, obviously the operation is reversed, but it has differences. As you can see, on the east side doesn't have the extension. In this case, all the regular lanes come into and enter. You have one entry point and two exit points going out of San Juan. And you can see as well that the busway operates inside the DTL on the flow of congestion, and then it returns back using the regular lanes on the other direction. Okay, so this is just to give you a sense of what the corridor looks like. Obviously, those are the details at the moment. We had toll transaction data that we use thanks to the Puerto Rico Department of Transportation and Public Works and the operator Metropistas. They allow us to use toll transaction data from 2019. The size of the database required detailed coding using Python. As you can see, for the size of the database, we are talking about in total 189 million lines of data. So obviously Excel doesn't cut it on this analysis. But the spread, as you can see, we have a total of 170,000 transactions for the dynamic toll lanes and about 15 million transactions for the general lane. So that's the data we use for the analysis. And I'm going to show you a little bit of the behavior. As you can see in the figure, you can see the traffic counts for the general traffic lanes and the dynamic traffic toll lanes in 5-minute intervals. And we are comparing that against the price of the dynamic toll lanes. And this graph shows the morning operation. You can see that traffic, as expected, on the general lanes increases. It reached up to 300 vehicles for the 5-minute period. That peak period on the general lanes is from 6 to 6:55 a.m. in the morning. So we are talking about this period here. As you can see, this is the peak period for general lanes. The rise in the traffic flow in the dynamic toll lanes continues a little bit after that peak point for general points and reaches about 120 vehicles in the 5-minute period about 7 a.m. in the morning. So you can see that those peaks on the two type of lanes, and notice that during the peak period for the DTL, the traffic on the general lanes is reduced. So you can see that in this period now people are moving into the DTL, and that takes traffic away from the general lane. So as expected, when you see that behavior, the price of the DTL obviously increases as more traffic goes into the express lanes. So the algorithm is behaving like it should. More traffic enters the DTL, speed on the DTL gets lower, so they increase the price. So that's at least that's as expected. Obviously, the rate of change is not constant. It's not constant. You can see that there's a big jump here, about 610. You can see a jump in $1 in the price of the DTL between 6 a.m. and 6 and 10. So you can see that it's a huge increase in price. When you see speeds now on the DTL, sorry, I'm here. In this one, you see the speeds now of the general lanes and the dynamic toll lanes. Again, for the 5-minute periods, you can see that the dramatic drop in speeds in the general lanes as the facility gets congested. At about 6:55, the speed on the general lanes reached the minimum value of 25 miles per hour. So you can see the huge drop in speed at about the same, obviously, position with traffic increasing. On the DTL, the speed drops around 14 miles per hour only. So it goes from 64 to 50 miles per hour at about 7 a.m. You can see the reverse trend between speed and the price. Obviously, it behaves, it confirms that the algorithm behaves as expected. You have less speed on the DTL, you have more price to pay on the DTL, and it reached up to 495 maximum point or maximum price that is set on the algorithm. So as you can see, speed is one of the performance measures that obviously we need to use to evaluate the performance of the managed lane facility. One limitation that we had on the study is that we only could estimate speed for the morning operation. We didn't have data to collect speeds or analyze speeds on the PM operation. So I'm going to show you only the traffic flows on the afternoon. Now you can see that the peak period is not as obvious as in the morning. Traffic now is more dispersed, even though the volume is higher, but it's more spread throughout the afternoon. Now when you see the share are similar, are more or less 33% of traffic goes into the DTL, either in the morning or in the afternoon. So the shares are similar, but the amount of vehicles are not the same, and that's something interesting. Obviously, we are looking here at the average values throughout the year. Another interesting issue is that the maximum price is not reached on an average. As you can see, it doesn't reach the 495 when you see the data group for the whole year. So that means that on some days, the pricing of the dynamic toll lanes doesn't reach the 495. So we are going to talk now a little bit about the economic measure that we collected at the project. For this we use a survey. We conducted a survey from October to November, and the purpose was to get information about the use and frequency of the DTL, and we performed this online. So this is an online survey with a 4% survey error. We received 518 responses. In terms of the sample, the average age was 45 years old. We had about the same quantity of male, female, were more or less distributed equally. And 65% of the sample either work or study on a municipality near the PR-22 corridor. And 76% of those that answered the survey stated that they have used the DTL before. So that gave us a good impression that our sample was representative of actual users of the freeway and the DTL. So with that, I'm going to show you some of those responses in the survey. We asked them what was the stated moment when they decided to use the DTL. And you can see that almost half of the stated users for the dynamic toll lane stated they decide to use the facility when they observe the traffic conditions on the freeway. So they have direct feedback. When they see the traffic on the entry point of the DTL, that's when they decide if they want to use the DTL or not. So half of them stated that preference. Only 21% stated to make the decision when they receive an alert from a trip mapping application, Google Maps, Waze, or whatever they use. They have an alarm that there is congestion on the corridor. 21% said that they use that to make the decision. Only 14% stated that they use the price of the DTL to make that decision. And I have to note that the only information that the user has about the DTL condition or traffic condition on the corridor is the price of the DTL. They don't receive any other information like travel time savings or level of delay, nothing like that. They just see the price. And with that, obviously, frequent users can analyze the situation and have an opinion about, okay, if I see a high price, I have to assume that there is congestion on the corridor, so I better use it. That's the only information they have. On the figure on the right, we ask them about the relevance of some factors when they decide to use the DTL. So we have 6 factors. Out of those, the most important was the congestion on the general traffic lanes. 91% stated that the congestion on the general lanes was an important or very important factor in their decision. The other 2 factors in relevance were travel time savings and the trip urgency. So if I'm running out of time, that takes obviously an important factor in my decision to use or not the DTL. The price of the DTL was the 4th factor in importance. So you can see the only information that they directly receive from the freeway is the 4th factor in importance. The other 2, climate condition or safety, as you can see, were not really that important to more of the users of the freeway. The other 2 questions I'm going to talk about is one about the opinion. We asked them using a Likert scale their opinion about the quality of the DTL. Almost 45% said that they have a neutral opinion. It wasn't good either bad. They didn't want to compromise on opinion. But 40% stated that they have a good or very good opinion about the DTL. So that percentage of positive opinion to the facility might indicate that the respondent recognizes benefits and provided an alternative to traffic congestion and an improvement in the quality of the trip. So that's good that the majority, in this case 40% of those who are not saying neutral, have a good opinion about the facility. But when you see on the right side, the other figure, we ask them about the perception of the reliability of faster trip. You can see that they understand that the DTL is reliable, but the half of them doesn't think that it's a good value. So the premium that they pay, they don't feel that they provide enough utility for their trip. So now you can see there's a little bit of contradiction on their part, which is natural when you talk about survey responses, but also talks about their willingness to pay for the use of the facility. So that's why we decided to include in the survey willingness to pay assessment. We use 2 different methods. One that is called Van Westendorp price sensitivity meter that use 4 questions to ask people to establish which price they believe the facility, in this case, or the good that is being consumed has it is too cheap, it is cheap, expensive, or too expensive. Okay. The other method that we use were stated preference scenarios. We show them variation of travel time savings and toll price and ask them if she or he will be able to use the DTL if they decide to use the DTL. So in that case was just a yes or no question. Obviously, I don't have time to go into the details of how these results are calculated, but those results that you have 4 prices that each respondent provides you are plotted against each other. And the intersection of those graphs are the ones that are being used to establish the willingness to pay, a range of the willingness to pay of those respondents. So as you can see from the graph, in this case, the arrow is showing the range from $1 to $2.79, and that's the aggregate willingness to pay of all the respondents. It is a range, it's not a specific price point, and that provides obviously some flexibility that you can establish if, in this case, the high price of $4.95 is outside of that range. So people will not be willing to pay that amount of money unless there is a an incentive that they can use to justify that payment. Okay, so an increasing, we also look at the socio-demographic characteristic. An increasing income was found to be not related to a higher willingness to pay, and that's something that in the literature we have found out as well. So if you have higher income, doesn't mean that you are willing to pay more. Also, females have higher values in willingness to pay. So that's very interesting in terms of human factors, why females are more willing to pay than males. And also, the higher the age group, except those who are 65 years old, those have higher willingness to pay. But the people who are retired have lower willingness to pay. So if you are retired, you don't have the pressure of getting into time. Most of the cases, you don't have the pressure to get to a job. So they don't have that willingness to pay. The other analysis, the willingness to pay based on the stated preference, we included 3 prices and 3 travel time savings. The table shows you the percentage of people who select the DTL, and there are no surprises. The scenarios with higher travel time savings and lower DTL price had higher percentage of selections. But we use this information to calibrate an utility function, and that's the one I want to show you, the result. We had 2 calibrations, a base model only with cost and travel time, and another with a full model with all the socio-demographic characteristics. As you can see, increasing price and reduce travel time savings obviously reduce the probability of a person selecting the DTL. So that's no surprise. Obviously, those 2 were significant, very, very highly significant. What other explanatory variables we found? Well, we found that subjects that have stated to use the DTL have more probability of selecting the DTL. So that's, again, that's an obvious response. A subject with an age higher than 45 years old, which is the Puerto Rico median age, is less likely to select the DTL relative to those who are below those 45 years old. Subjects with incomes in the mid-income and high-income categories are less likely to select the DTL. So it's consistent with what we showed in the previous method. If you have higher income, doesn't mean that you are more willing to use the DTL. And again, males are less likely to select the DTL. And that's, again, consistent with the previous results. With this model, we were able to calculate the value of time. So in this case, the estimate is $21.47. So $21.47 per hour is the estimate that people are willing to pay for travel time savings. Obviously, it goes to a range of an hour. So if the trip is lower than that, we have to adjust for that. So I'm getting like at the end of my presentation, I'm going to show you the performance metrics we collected for the DTL using the total transaction data. We calculated 5 metrics: travel time index, planning time index. We calculated speed threshold using the Federal Highway criteria. And we had 2 different metrics proposed in this project. One called the ability of toll to impact congestion that was proposed by Dr. Burris from Texas A&M, and the speed dominance indicator that was proposed by Dr. Rodriguez from our team. Obviously, the other metrics are common. The TTI is a calculation used for the urban mobility report, just defined as the ratio of travel time conditions in the peak period to a target. Our target was the free flow. In the case of San Juan, TTI is 1.3. So you can calculate travel time and then calculate the difference between the general toll lanes and the dynamic toll lanes to get the savings. And that's the save time by the freeway user when they decide to use the DTL. So the results for the morning operation, as this is a metric based on speed, we only have results for the morning operation. As you can see, there are obvious benefits in travel times when you use the DTL. Obviously, that's as expected, but we are confirming that free flow when you compare that the travel time during the peak hour, you can see the difference of about 7 minutes between the general lanes and the DTL. But when you see the difference in travel times, based on the TTI, you almost see that the TTI for the general lanes is almost twice those for the DTL. So obviously the pricing algorithm is working as desired by not allowing the trip quality to degrade in the DTL as much as in the general lane. So you can see that in terms of travel time, the DTL has benefits over the general toll lanes, and that's expected. But when we talk about the reliability of those results, and that's when the planning time index comes, you have the calculation on the screen based on the 95th percentile travel time. And now you take the ratio against the free flow. In that case, for San Juan, is 2.5, the entire general region. And then you can calculate the difference between PTIs, between general lanes and dynamic toll lanes, and get the benefit. So when we see the results, again, we confirm that the DTL is providing a huge benefit in reliability of travel time to the users. So now you can see that the 95th percentile of travel time, 12 minutes for the DTL, 27 minutes for the general lanes. So you have a difference of about 15 minutes in the morning peak. And when you see the difference in the PTIB, the benefit is 2.28. So basically, the reliability is improved by 22 minutes. And you see the example for a 10-minute trip. The difference on how much the user will have to plan to avoid being late at least one time in a month. So the DTL is providing benefits in travel time and in the reliability of that travel time estimate. So those two are shown in the results. In the case of ATIC, ability of toll to impact congestion, is basically a computation of elasticity. It talks about the effects of congestion when balanced by the increase in the toll price. So when you see the results of the ATIC, you divide it by periods. In our case, we decided to calculate ATIC separately for the increasing and decreasing traffic flow periods. We calculated for the entire period and we saw the same effect, but we wanted to see if there was a difference when the traffic was increasing versus when it was decreasing in the morning. The results are consistent for the morning operation, that the period when the price is from $3 to $3.99 has a negative ATIC value. That means that the price of the dynamic toll lane is affecting the decision of people using the facility. So it has a negative, effect of people not entering the DTL in the same proportion as the increasing in the price. In the afternoon, you can see that in the increasing period is not the same than in the decreasing period. In the increasing period in the afternoon, the negative value comes about $4 to $4.99, which is the maximum period. And you can see that at that position of price, it becomes negative, the ATIC value. So the price is making the effect that you desire, that you increase the price, so people don't go into the DTL as much and degrade the conditions on the DTL. So you can see when the price is affecting the perception of the user, and proportionally people decide not to use it. In terms of speed, this is the Federal Highway Average Speed Threshold. This is the one standard for HOV facilities. In this case, for Puerto Rico, it's a little bit of controversy because one detail I didn't mention, the speed limit on the DTL is 45 miles per hour. And the general lanes is 55 miles per hour. So you have a contradiction in speeds when the express lanes have a lower speed than the general lanes. So when you apply this metric, it shows you a little bit of controversy because you have to apply, as is stated on the rules, the speed limit as a threshold value. So if you have 50 miles per hour larger, the threshold is 45 miles per hour. If you have lower speed limit than 50, then you have to go to 10 miles below the speed limit. So when you try to analyze the Puerto Rico DTL using those concepts, it becomes a little bit, confusing. You can have the speeds compared from the general lanes to the managed lanes in 5-minute periods, and you can detect when the DTL have lower speeds than the general lanes, which obviously would be contradictory to the purpose of the higher travel, benefits. But when we saw the case A, and that's using 45 miles per hour, ignoring the speed limit on the DTL, the threshold is not met. So you have times, more than 90% of the time, that the speed on the DTL is lower than 45 miles per hour. So based on those rules, it won't follow the criteria. Obviously, like I said, for the DTL, the speed limit is 45. So the correct way of analyzing the threshold is using 35 miles per hour. And in this case, with a lower speed limit, the DTL behaves as the criteria established. So you won't see a problem if you ignore the fact that the speed limit on the general lanes is higher than the DTL. So, that's why I mentioned it's a little bit of controversy using this metric. And the last one, I know I'm reaching the end of the presentation, is the speed dominance indicator. This is proposed as part of the project using the dominance theory. To tell you in a quick note, it's just a calculation of the product between the traffic speed and the flow. So if you take the flow and the speed and you multiply it for the general lanes and you multiply that for the DTL, you will have that calculation and you can establish 2 points, one for the general lanes and one for the managed lane. And obviously you can take the difference like it's stated in the equation. With that, you get a perception of when the throughput multiplied by the speed is higher in the managed lane, providing you better performance. So you combine speed with flow in this metric. When you do that for the entire year, you will have a graphic like this one. This is a group in 5-minute interval. And you obviously, when you have positive values for this indicator, that means that the dynamic lanes are dominating the general lanes. When you see a negative value, it means that the general lanes are dominating the dynamic lanes. Obviously, what do you would like to see? That you would like to see positive values. So you can see that during the peak hour, from about 6 a.m. through 8:30 in the morning, the DTL dominates the general lane. So it provides a better output in terms of the product of flow and speeds than the general lane. So again, during the peak hour, the DTL is doing its work. It's doing the work that is expected. During off-peak, now you can see that the benefit of using the DTL is not really that obvious. People are using it, but they are not probably improving as much as during the peak hour, and that's obviously expected, and that's the actual performance that you're looking for at a dynamic toll lane. So in conclusion, when we analyze the data, most important factors that people stated for choosing the DTL was the congestion level on the general lanes, the travel time savings, but the urgency of the trip as well. And although the DTL was perceived as a reliable option for faster trips, obviously there is a disagreement with how good value the facility is providing for its price. And that was confirmed with the willingness to pay, the stated responses on the survey, and obviously you can see it from the actual traffic flow patterns. And obviously, like I said, the willingness to pay estimated for the dynamic toll lane is lower than the maximum toll rate. So obviously that comes into a question of how much is how much you can pay for the dynamic toll lane, and obviously the equity factor, which we didn't analyze at this project, how it becomes an issue with the users. And that's something that we should take a look at future projects. In terms of comparison, I will complete my presentation with this. We went back to the results of some of the performance measures that Dr. Burris calculated in his part of the project. He analyzed 6 different facilities, and I'm going to show you, just for review, 3 of the factors or metrics. Obviously, there were other metrics that were calculated, but I'm just focusing on these 3. As you can see on the last column, you have the Puerto Rico DTL. And you can see you have 2 variable pricing facilities, and now we have 5 dynamic pricing facilities. You can see Puerto Rico DTL has higher travel time savings and benefits in planning time index when you compare those with other facilities. So, and that's a result of higher congestion in the San Juan metropolitan area compared to those locations. So you can see that our facility provides higher benefits, like I say, in travel time savings and reliability of travel time. I added the speed threshold, and you see that there are 2 values. Obviously, we calculated 2 ways using the different speed limits, just to compare. In this case, 2 of the facilities analyzed by Burris didn't meet the threshold. Obviously, they used the higher threshold. In this case, Puerto Rico will be a no if we use the 45 miles per hour. So you will have another one not meeting the speed criteria. But remember that the speed limit is lower, so we have to go with the yes. The actual result is a yes, that it meets the speed threshold. So in conclusion, obviously Dr. Burris mentioned in his report that we need to find more data, more facilities in order to reach a conclusive solution, whether the dynamic pricing or variable pricing is better. In this case, we didn't find a substantial evidence, although dynamic pricing tend to be better. But we believe that there's still more data needed to reach a conclusion, a more solid conclusion. So in terms of recommendation are more local. I believe that providing more information to users using roadway signs can improve the capacity of people using the DTL by having more information. The issue with the speeds on the Puerto Rico DTL has to be conducted to see if those speed limits are related to any safety issue that can be improved, the situation. And also, Puerto Rico doesn't have a high occupancy vehicle policy. Maybe a project in the future might be to study the possible impact on the performance capacity of the DTL if we include HOV policy for the use of the facility or the freeways in general in Puerto Rico. So with that, I want to thank NICR for supporting this research, obviously as part of the grant from the Department of Transportation. And also I want to thank the Puerto Rico Department of Transportation Public Works, the Highway Authority, who provide the authorization for use the data, Metropistas, who is the operator of PR22, who gave us information and the use of the data. And also I want to thank the Texas A&M Institute and Dr. Burris for their collaboration during this project. So with that, Stephanie, if there are any questions.
Thank you so much, Alberto. As a quick reminder, the Q&A box is located on the bottom right-hand corner of your screen. We've got a few moments for some questions. I will note that one of our previous webinars from earlier in March, Dr. Burris presented on the research that he completed through NICR as well. So if you're interested in seeing that recording, I will add that to the web links section. One quick note here, Alberto, someone mentions FYI, the SR91 facility is not subject to federal performance standards.
There are some local, I didn't mention that, there are some local standards also that they can use. So I just focus on the federal side. Thank you.
Thank you. Okay, so let's go through some of these questions that have been submitted. The first question comes in and says, how the results from the willingness to pay and the value of time analysis can be used to improve the efficacy of managed lanes facility?
Yes, that obviously is related to the economic measures that we obtain from the survey. And obviously, if we look at the consumption of a good, if we look it through that theory, obviously the DTL, the use of the DTL is a consumption of a good. So anytime that you can relate the performance that you see in terms of traffic flow, speeds, and you can combine that with the perception of the user or the potential user, you can make better decisions. In this case, the better decision might come in the analysis of the algorithm used to establish the dynamic pricing. If you have information about the willingness to pay and you can analyze how much people are willing to use, obviously with some limitation about the capacity of that information to be real, obviously there are opinions, but you can use that to calibrate the pricing mechanism to improve it and see if that can increase the throughput of more people going through the corridor, because the dynamic toll lane is just one part of the equation. If you are going to analyze not just how many people use the DTL, how many people use the corridor itself, it can give you some insights that you can adjust the pricing and see if that improves the capacity of the entire corridor and obviously reduce congestion that way.
Perfect, thank you. We'll take one more question. The stated performance analysis included 9 scenarios with values of travel time and toll rates. What was the basis for selection of these values for the survey?
Yeah, in that survey, we have the 9 scenarios, and obviously, when you see the literature, there are no obvious criteria how to establish the scenario. So in this case, we use the actual price of the dynamic toll lane, that is $4.95, and that's basically was like a middle point. Obviously, we use 4, and then we decided, okay, let's double it. And we decided to use $4, $8 as 2 of the options, and then the lower price will be $1. And one conclusion that we reached is that we don't know if when people did this question, if they consider the price of the fixed lanes, the fixed price on the general lanes, that is basically $70, 70 cents. We didn't know if the person considered that in their decision, because they have to pay a toll anyway if they don't use the DTL. If you are inside the freeway, you are paying a toll of 70 cents. So that basically the minimum value for the DTL is $1. So we use that as a minimum value in the survey. And then the actual travel time savings, we use them. We have already data, and we collected that data of travel time in the corridor, and we used it. The maximum we saw was about 15. So we tried to be as more realistic as possible in terms of those options. We didn't want to show them, okay, what you will do, you say 1 hour. But that won't be probably too true for most of them. But 15 miles per hour, 15 minutes, sorry, it is an actual value that they can have from the use of the DTL. So those were our criteria to select which values we use for the stated preference.
One additional question came in while you were answering. It says, is there a tool that analyzes the data?
Yeah, we are working on that of see if the authority or the operator wanted to have a dashboard with the data. So they, as obviously operators of the system, or even the users, can take a look at the data and see different analysis using these metrics, so they can do better decisions. So yes, the researchers are talking about doing a dashboard that can be implemented on the web, and then the highway authority or the people from the operator can use it. The user can go and log in and take a look at the data and probably that will also help some people to be better informed and use the DTL as well. So the answer is that we are working on that.
Okay, thank you so much, Alberto. I am going to open up the evaluation on your end. We have reached the end of our time together. So do please take a few moments to complete that evaluation, as the feedback provided is not only important to Alberto, but the entire NICR webcast series. I will let you know that our next webinar is scheduled for 2 weeks. Our partners at the University of California, Berkeley will be presenting on what the role can the built environment and incentive supporting polling with shared mobility. Excuse pooling with shared mobility. I apologize. A photo voice study in the San Francisco Bay Area. So on behalf of the National Institute for Congestion Reduction, thank you so much for joining us today, and we will see you in 2 weeks. Bye, everybody.